Let's go ahead and start Module 3.
You want to start Module 3?
Welcome back. We're at Module 3. All right, so right now we're going to talk about some of the data capabilities inside XAML, and we're going to talk about especially how you would use XAML to make your data, make your UI, just lay it out the way you want it to look.
Yeah, you got there eventually. Yeah, we're going to do layout.
All right, yeah, nice.
Okay, so as Jerry just mentioned, layout and data binding is the focus. Obviously, he touched on data binding a little bit beforehand. So now we're going to talk about really what's the purpose. Why are we worrying about layout in Windows 8 applications? You know, it's full screen. Why do we need anything?
Well, there's a couple things. First of all, you want just things to look right? We just start from the basics of why you want things laid out. But there are strategies around layout as well. Like one of the things you want to think about when you build it is to make sure that it reacts. We talked about different size monitors when you go from, say, a surface to a screen. And you want to be able to build a layout that's responsive, not just to the user's interaction, but also responsive to changes in the environment like that. When it is bigger, when it's snapped all of a sudden.
Yes. So people in the web world have been dealing with this for quite some time, you know, different screen resolutions, flowing the layout, and so on and so forth. So it would make sense that a rich presentation platform such as the Windows 8 and the XAML stack would have something similar to that.
And it does.
It does. Very, very fortunate.
It does indeed.
So as Jerry mentioned, we've got different sizes, different orientations, and we have controls that allow that UI to be managed. We have a typical application layout, which really kind of starts off with a frame that contains child elements, which may be a page, which derives from a user control.
Yep.
And within that page, we typically have a master layout component, which is typically a grid, and we'll touch on that a little bit. And within there are controls. But the interesting thing about this is, how does this layout happen? You know, we just throw things inside it and it just magically presents. In your earlier demo, you showed putting a red rectangle that was sized to 100 inside the button, and the button magically grew to accommodate that.
Right.
Now that's pretty interesting. You know, how does that happen?
Well, the button itself is already responsive, right? It was written in a way that it would respond to whatever the data is in it. Lots of that technique is what we are wanting to do. So we're going to be talking now not so much about the control itself, but these containers of controls that allow the flow of all these things that you have. Especially, and I don't mind saying, this is really around data, right? This is really around, because you probably can control your applications look and feel pretty easily from screen to screen until there are some unknowns. And when you have a repeater that's repeating this data, now suddenly you have some unknowns. How far out does it go? How much data? How big is the data? What if it's really descriptive and you have a lot of text? What if it's really short and you don't?
Yeah. So one of the key things around this layout is there's multiple passes to this layout in that you have a container that has children. How does the container know how much space each one of those children needs? For example, you talk about a piece of data element that you want to display. How does it know? Well, it asks. Yeah. So it turns around and requests of the child element, how much space would you like to have in the ideal world? And the child says,
yeah, so you have a control, first of all, that you would give a size to, right? So you have an explicit size set to it, the width and the height. Say, like I did 100 by 100 for that rectangle.
Yep.
But then you also have a desired size, right? And that desired size is going to tell you, based on the content that's inside me, this is the size that I really should be. And a button would have that.
Yep. And so these child controls can request that. The interesting thing is that the container uses that as an advisory information. You know, the container turns around and says, well, I only have so much space. Therefore, the amount of space you have to render is this, and then imposes a rendering size. Now, obviously, everything tries to accommodate these requests, because generally there's a good reason if something is specifying height and width. But one of the key things to take into account when you want to build this responsive layout is trying to avoid specifying hard and fast dimensions.
Yeah, there are only so many pixels, right? And so you have to just realize that based on the actual size, you are going to be constrained. The parent can constrain you, the size of the window can constrain you, and there are these, if you're going to, it kind of goes back to toast notifications, in a way. If it becomes absolutely imperative that whatever this control is a certain size, you had better understand the layout of XAML and to make sure that that size doesn't change.
Exactly. For example, if we're looking at the snapped view, which is presently constrained to be 320 pixels wide, if you have a control that you've said has to always be 500 pixels wide, placing it in that snapped view doesn't make any sense because it's always going to be trimmed. And there are certain strategies you can employ to actually ensure that the content is presented correctly in that scenario.
So you would set the height and width. You could also set and then it would generate a desired height and width. But then there is an actual height and width.
Yes.
And that whatever it's really rendered to be. And so there are 3 possible sizes.
I see what you did there. You mentioned render as well.
I know.
What's the difference between render height and actual height?
Well, there's no difference. But they both communicate the same thing nicely,
exactly.
For sure. The actual height and the rendered height may not be queryable. It is possible that you can't determine it, and so it's not going to give it back to you. Or a timing issue, it hasn't totally been rendered yet, and you're asking for it, and you can't get it. But there are these 3 views of it. I want it to be 100 by 100. It wants to be 200 by 200 because I put so much inside it. It will obey my explicit. I don't give it one. I just say make it auto height and width. Yep. Now the desired will be the height and width that it tries to grow to, but it will be constrained by wherever the container it happens to be put into.
But width and height would be not a number.
It would be not a number.
Yeah, NaN.
That's exactly right.
So
it would be, which would translate to auto.
Exactly.
Or star if it were in HTML.
Exactly. So we have these common top-level containers, and Jerry touched on them in his exploration of XAML beforehand. We have the canvas, we have the stack panel, and the grid. Now they each perform a different set of activities really in the role. If we look at a canvas, canvas is it's your default painting service, if you like.
Web developers watching, the corollary is the canvas.
Exactly, in HTML5.
Yes.
You can position anything anywhere you like. You specify the absolute position of that child, and it will not flow. So if you shrink the canvas down, if you change the size of the container the canvas is in, the position of the child may well disappear off the viewable area. That's what the canvas does. Yeah.
There are a couple of important things is, when would you choose the canvas? You would probably choose the canvas if you were writing a game. That's a very common scenario. What are the benefits of a canvas? Certainly the benefit of the canvas is that manipulating things inside of it, you can control Z order, which is very special. You can, of course, control its position inside it, and manipulating its position, especially with transformations, are all GPU accelerated so that you can offload that from the CPU into the GPU. So there's a lot of goodness around Canvas. I mean, if you think about what you're going to be doing when you're playing a game, you are going to be moving stuff around.
You're moving bitmaps around, very finely positioned, and you want to absolutely specify where they are. Yeah. And so that's the canvas. Flip side is it's the least flexible if you want it to participate in a collaborative layout system.
Yeah, that's right. Because you really are saying it goes here, and it's you're not saying relative to, right? Yeah. You're saying a specific top left, or right, or bottom.
So if we look at this slide, we can see here's an example of leveraging the canvas. And so we have the canvas elements, and we have 3 child elements, a rectangle, an ellipse, and a polygon. And we'll be reusing these to demonstrate the different capabilities of the various panels. So what we can see here is that, in effect, they are stacked on top of each other, and the Z order is implied by the order of declaration. So the rectangle is in the background, ellipse is in the mid, and the polygon is in the foreground.
And the reason they're stacked on top of each other is because you didn't say the top or the left they're going to be, so the default is 0, 0, so they're all sitting right on top of each other.
Exactly. And so that's the default activity within the canvas. Now you could go and specify left, right, up, top left, and so on to move these things around. But again, it's not going to react based upon the size of the canvas.
Great, yeah. So there's the corollary to Canvas is Canvas in HTML5. We also have the stack panel, which the corollary would probably be the div tag, I suppose. I don't know, everything.
Yeah, pretty much everything is by default is stacked hierarchically.
Yeah, in HTML. HTML. How do you do that in XAML? You do it with the stack panel, and the stack panel allows you to stack both vertically and horizontally.
Yep.
Right? Very nice. And I use the stack panel everywhere, constantly.
One of the key things with the stack panel, however, is it sizes itself infinitely based upon the requirements of its children.
Yeah.
And so by default, it'll zoom on forever, and unless you use anything else to put bounds around it or provide some means to navigate the full extent of the stack panel, such as a scroll viewer, you could have elements that are shooting off the screen and you have no means to navigate to them.
Yeah. I suppose you could put a height or a max height or something like that, or a max width or whatever. But at the same time, now you're going to have to scroll to them in order to figure all those extra pieces out as well.
Exactly.
It doesn't solve the problem.
And as soon as you start putting these hard-coded dimensions in, then you have the problem that, okay, I might have solved it in one orientation of the application, but if I move to another orientation, then those hard-coded values don't make any sense. So if we take a look at this particular example, we have our same child elements, rectangle, ellipse, and polygon, declared in the same order. And what we have here is we've specified a stack panel with a specific margin and so on to create gaps around the elements and so on for positioning. We've also specified some macro elements around the stack panel which positions that on the page itself but doesn't impact the children. And we have our rectangle, ellipse, and polygon arranged in the default orientation, which is vertical.
Yeah.
And so we can see the difference here between what we had for the canvas, where everything's piled on top of each other. In the stack panel, as the name would suggest, it's stacked.
And each of the pieces in the stack panel don't have to be the same size. The stack panel will reorient itself naturally to handle that. So if you need to put a grid, and then you need to put an image, and then a button, and they'll all be together, and they'll look ugly.
Yep.
But you can do that. I mean, you would
Yeah.
use a stack panel on things that you know need to be on top of each other.
Just because you
need to be
can
side
doesn't
to
mean
side.
you should.
Exactly. I have our app up here so that I can really show how it lays out. And so if you so check this out. So on this can I look at that, the fingerprints.
It's right there.
Oh, that's awesome. Yeah. Well, as you can see right here, this is the stack panel vertical, and they all sit together, and if this is exactly the code that you showed in the slide, and it just sits there showing the same objects different ways, and it's really nice. So obviously, I can see at the top, we're going to go to grid next, the 3 main layout controls.
Yep. So the grid is most commonly used if you want a responsive layout. The great thing about the grid is, as the name suggests, you lay things out in rows and columns. It allows you to create a layout with controls positioned relative to each other. You can specify how many rows and columns you should have in your grid, which is very useful. And the key thing about the grid that I think makes it ideal for this responsive layout is how you can specify dimensions for your rows and columns.
Yeah.
You know, your ability, there is this capability called star sizing, which allows you to basically state that this column or row is going to expand to fill available space. You have fixed point, which you can use, which we actually use for the top of the UI to show the buttons for navigating between the various views of the layout panels.
Basically saying that a row or a column needs to be exactly this size and don't change no matter what.
Exactly.
Right. And step back just for a second. The grid, if you're a web developer, its most corollary is the table.
Is the table.
In fact, it acts just like the table. If
It
you
does.
understand the HTML table, then the translation over to the grid is very simple.
Now, the interesting thing is there is a lot of calculations that have to be performed to achieve the layout of a grid in terms of each of the elements need to be queried on what size they desire and what size they can actually have available. So in the same way that when you're rendering a HTML page that has a table in there, where there's a lot of parsing and so on and so forth, the more complex you create your UI, the more workload you're actually putting on the rendering system to actually render these things out. So be aware when you're creating this complex layout that
There's a cost.
There's a cost.
Absolutely, yeah.
You know, if you make it infinitely sizable and you have grids embedded within grids, and so on and so forth, you're creating a lot of processing on every rendering stack, which may make your application not as responsive as you're looking for.
I like to think, I tend to avoid grids, generally speaking. I don't, though, on every page. I have a grid every time, but I tend to think of it, the grid is your initial layout of the zones of your UI, because it does allow it to be flexible regardless of the size. But then inside the grid, inside those individual cells, like in a table, that's where you use these other controls, like a stack panel, right?
Exactly.
Yeah.
And so,
or even a canvas, right? You would put it inside so you can make sure that your logo is always visible or something like that.
absolutely, it's kind of your default infrastructure for your page layout.
Yeah, that's right. So these are the 3 that every developer has to use in order to build the general layout of their UI. Right? We have the stack panel, the grid, and the canvas. Many developers will never use the canvas. I mean,
Many developers will not.
Yeah, the grid.
You
and
mentioned
the stack
gamers. I mean, those are primarily the target, I
Yeah.
think, within this environment right now. If you're building a XAML game, you're going to be using
If you're not
Canvas.
building a game and you are using XAML, you need to ask why, right? You better have a reason. And sometimes there are scenarios.
Yeah, absolutely.
Yeah. Okay, so we have the grid, and we also have other containers.
We have other containers, and so these are generally used in concert with another panel or another control that may contain items. So we have wrap grid and variable size wrap grid, which is a very, very powerful control.
Yeah, no doubt. So the wrap grid, we don't use these standalone, right? These are things that add to others. Same with the variable size. So the common use of the wrap grid is inside the grid view, a control we'll talk about later. So the grid view is the most common data repeater inside Windows 8 in the standard controls. And that wrap grid, it shows everything in uniform grids. If I were to go to my start menu, it's a uniform set of grid. But it's not totally uniform because, see, this one is a little bit wider than the others, and this one's a little bit wider than the others as well. You can see the Redmond weather's a little wider, but this one is square. Well, since it's not uniform, I know that they're using the variable sized wrap grid. I can do the same thing inside my applications. The variable sized wrap grid is a powerful way of adding. So earlier we were talking about using the style guidelines, and that gives visual alignment from application to application. But you can also add visual interest to your application. One of the ways is just to vary things up a little. Variable size wrap grid allows you to do that. In a lot of ways, it's just spanning columns.
Exactly, and that's a key thing. We didn't touch on that on the actual grid earlier on, but each one of your cells can be set up to span multiple rows and columns. So again, you can add that visual interest and create a very flexible layout without really going into that.
Reflecting back to our previous module, it is the use of attached properties that allows us to say grid.row equals grid.column span equals, or things like that.
So why don't you bring up the wrap grid example?
Yeah, absolutely. Here's a wrap grid.
So one of the key things that you can do is you can actually apply constraints to your wrap grid, so it doesn't end up creating 15 rows down and they're zooming off the screen. You can turn around and say, for example, in this particular demo, we've constrained it to a maximum number of 2 rows or columns so that we can show the wrap around.
Yeah, the green triangle could fit here below, but it doesn't. That's because you've said maximum rows is going to be 2.
Exactly. So we also mentioned earlier on the...
By the way, though, if you didn't say maximum row equals 2, and I was on let's say like an 80-inch screen, it would be a beautiful way of taking advantage of all that extra space because the wrap grid just reacts.
Exactly, and that's its real power, is, if you go back to your home screen, where you have your start menu, and you can see how many tiles are stacked out there. If we were on a different device with different screen size and different DPI, you might have 6 rows.
Yeah,
and that's
exactly
just
right.
done for us by the combination of the wrap grid inside of Vue.
Yeah, it's pretty powerful. It's very powerful.
Yeah.
Yeah, it's one of the things that you shouldn't look past. Now, often developers will be using the wrap grid without knowing it because it is the default panel inside most of the repeaters that are native to Windows 8.
Exactly. So one of the other demos that we have on there is a stack panel inside a scroll viewer.
Oh, yeah.
So if you bring that one up.
Something's funny about this triangle.
Yeah, it seems to be truncated.
Yeah, well, of course, what we really know is that it's off the screen.
Exactly, and so we've put this stack panel inside a scroll viewer, and so that gives us the ability to move the viewport to display areas off the screen. So if you scroll down...
Well, let's start with like debunking an assumption the developer may have. It might be that if a wrap panel goes off the screen, then the user can scroll to its additional content.
Yeah.
If a stack panel goes off the screen, then the user can scroll to the additional content. Neither of those is true. If you want it to scroll, you implement it with the scroll viewer.
Exactly.
And so here it is. This is the scroll viewer using the exact same demo from the stack panel. And now I can go down and see all of it because I'm using the scroll viewer. So let's look at your slide. We can see the syntax, and it's very simple. You just wrap it in a scroll viewer.
Exactly, yeah. That's one of the great advantages of this. It's very, very consistent. We just encapsulate within it. This content is then rendered up inside it. And as you can see, I've taken the regular 3 elements and I've just repeated them. Because we're in a stack panel, it creates a stack. The size of that is greater than can be rendered on the screen itself. And the scroll view just sizes its scroll bar to be able to navigate that content.
So we're showing a scroll viewer that can scroll vertically. How do we scroll horizontally?
we basically extend the content out the other direction.
Yep.
We can also specify which directions the scroll viewer supports. We can also control the visibility of the scroll bars.
Yeah, this really is a lot like the overflow, the CSS attribute overflow.
Yep.
Where you can control the X and the Y, set it to be auto, set it to be on, or set it to be hidden, right?
Yep.
Or visible or hidden.
Absolutely.
And we can do the exact same thing where we can make sure that the scroll bar is always visible or only visible when you want it to be. Yeah, it's very nice. And you can disable it as well. And so I could scroll vertically, but I can't because I've disabled scrolling. A lot of power.
A lot of power. You really need to consider what you're presenting and how you want it to be presented. You're considering the user experience that you're trying to create when you're placing these constraints on these controls.
Yeah, it's neat. A lot of these controls really help solve these problems of changing devices because it works on my machine is the developer mantra, and of course
Exactly.
I'm building on this awesome gigantic screen, and then you go to run it on this tiny little screen. Half of my app is invisible to you. The right thing is not for me then to just create a gigantic scroll viewer for you to find it all. Right?
No, we don't want to end up having to scroll 15 times to the right to try and get something in
What are
there.
some of the options developers have?
So one of the key controls I think that facilitates this flexibility is the viewbox control. And the viewbox allows us to size content based upon the constraints of the viewbox. And we can specify some rules around how it does that. We can turn around and say none, which is pretty much the same as not having it inside a viewbox.
Yeah, talk about a waste of time.
Exactly. But fundamentally what it does do is clip to the extent of the viewbox. You've got fill, which tells or takes the rendered content and then distorts it to fill all the available space.
Yeah.
So you could, if it's wider than it is tall, it may compress it in the horizontal and stretch it in the vertical to fill the space.
I have the demo here. Let me pull it up in the designer, and we can go through these non-fill uniform together, and we can see what the designer shows us. Because it's actually, it's actually really interesting. Let me see. Got it right here. Here we go. Nope, wrong one. Sorry. There it is. Okay, so in the, let's see, we were in the view box. So it's already set in the demo here to fill. No, it's already set to uniform. Right here.
Which is the default.
So let me describe the demo real quick. So we have this 3 set together. So we have the square, circle, and triangle, and then we have the square, circle, and triangle in a smaller region, a 320, which just happens to match to the snap view. And so these are exactly the same. One just happens to be wrapped in a view box. In fact, let me. There we go. They're both wrapped in a view box, but one doesn't need to do it, right? So this one fits perfectly inside this area, and this is the view box that now is set stretch uniform, and it's set in a small area. All it does is just automatically scale it down so that it fits nicely. And since it's set to uniform, that's the prettiest.
It's scaling all dimensions in the same way.
That's the prettiest. Now, we might want it, so the first one we might say none. Remember when you said that? So there's none. It takes it back to its original size. You can see this top view box is actually scaling it just a little as well. Because if I set it to none, it brings it down. So that's the original size. So it was actually scaling it up just a little bit. And so now if I go over here and I say this view box, I don't want it to be none. I want it to scale and fit a little bit. What was the other option?
So you got fill?
Fill. So here's fill. So fill is horrible. Right? I mean, I could see a few scenarios where you might be able to use it, but generally speaking, it's just not what you want, right? But anyway, it fills all the space, all vertical, all horizontal.
And it distorts. That's the key thing, is to understand that it's going to distort any element that you have inside there.
Stretch is also a property on the image tag.
Yeah.
And how many people misuse that and they just goof up and everybody looks way too fat or skinny.
Yep.
Okay, so we have fill.
That's your excuse anyway.
Yeah, it's not. Blame the image tag. Stupid image tag. Wouldn't that be awesome? Never mind. Let's go. All right, so back to uniform. Uniform is...
Stay on target.
Uniform says fit it in the space. So the uniform says bring it back to and make it fit inside the space. Adjust anything you need to, but don't mess up the aspect ratio.
Yep.
Right. So uniform is great. I like uniform a lot. Sometimes that leaves kind of like letterboxing.
Yeah. Either horizontally or vertically, you're going to have these borders around it depending upon the factory views.
The last one is uniform to fill, and it's a weird combination of fill and uniform.
Yeah.
Right? I mean, talk about one that's really crazy, but it's sometimes it's great for like background images or something like that where you don't know if it's going to fill or not, but if it does, do it. If otherwise, go. And so if I were to select it, now it says let it grow until it fills it. Let it grow with the aspect ratio until it fills all of the pixels of this container. And so that's what it's done. And of course, as it grows, since it can't squish it, only the square shows up.
Perfect.
Yeah. One thing we didn't talk about that I think is worth talking about is if I were to run this and show you the scroll viewer. The scroll viewer, remember, of course, it scrolls fine, does touch just as easily, but it has another neat feature, this built-in zoom that's there. And sometimes this throws developers off because it's defaulted to on. And so if I have, in this case, I just have some content in here, but if I do the semantic, or not the semantic, but if I do a pinch zoom, right, I can actually start to shrink it and see the whole thing, and that's built into the scroll viewer.
Yeah.
And because it is defaulted on, sometimes it blows developers' minds, right? They're accidentally enabling zoom when they didn't mean to. But it is a nice and powerful thing. If all you wanted was to show, let's say it was an image, wrap it in a scroll viewer. Now the user can interact with it and have all this functionality without having to do very much.
It's one of those incredible things you can get for free. And but as you say, it can really surprise you sometimes if you go, oh, what the heck has gone on here? Yeah,
no doubt. It's pretty neat.
Yep.
And of course, it's doing this. We know that it's doing it with the scale transform. We'll talk about transforms in the next day, right? When we do the next one. But scale transforms are the GPU accelerated way to scale items. It's really nice. Does it all correctly for you, I guess is what I mean.
Absolutely. Okay, so that was kind of a very whistle-stop through layout
controls.
Yeah. There's obviously.
Then what's nice about it is there really are three.
Yeah,
canvas, stack panel, and grid. You learn those, and you're well on the way.
You're certainly well on the way. If you understand how you can leverage the scroll viewer to be able to take extra content, then you can start to think about, okay, so a list view, it has a whole bunch of things that are stacked, and that stack is inside something I can scroll. And that's the foundation for building all of the more complex controls.
Earlier, when we were talking about the difference between a logical tree and the visual tree, the logical tree says you have a list view and some boxes. The visual tree, now you know there's at least a scroll viewer in there. And you know there's probably a wrap grid, right, as well.
Absolutely.
Yeah, it's really nice.
Okay, so in a somewhat jarring segue,
bam,
we're going to leap from layout, and we're going to talk a little bit more about data binding.
Good. We touched on it in the last module, and I love data binding. It's probably the most powerful part of XAML. I mean, some would argue, because it's one of the neatest things.
Well, the XAML is the most powerful part of XAML, but yes, it's certainly...
I suppose so.
It's certainly a very important aspect. You couldn't build dynamic applications without having some form of way to inject data into your application. As we talked about earlier on, we could hard code everything, but that's hardly a dynamic application. We can put in our constants. We talked about, we could localize things and we can break things out to resources and so on. But again, those are things that are declared within our application. It doesn't respond to new data that's coming in. So that's where data binding comes into play. We can present dynamic data. We can use it to connect to a data source, be it internal or external. And we kind of touched on the idea of a view model, that a view model is a class that is responsible for shaping data for display. It's responsible for manipulating one or more models to get that information and producing something that we can then present.
Yeah, that's exactly right. And more about data binding would be, I can now bind into the classes that I have so I can interact with the UI from code. But data binding is even more too, right? I can data bind I can bind to the data, I guess is better.
Yeah.
But I can also bind to anything. I really can. I can bind to another control that's my sister control, let's say.
Yep.
I can bind up to my parent. I can bind to the template that I'm rendered inside of. I can bind to something that is distant on the page that I want to interact with. And that probably fills it out and really makes data binding unbelievably powerful. If we were to look for a corollary in HTML now, we wouldn't find one.
People have created lots of frameworks that do it, such as Knockout.js and so on and so forth, that provide this kind of binding capability and so on and so forth. But the thing to understand about this inside XAML is this is inherent. And the reason we're able to do this is there's these things called XAML extensions. You have the ability to create extension syntaxes. And Jerry kind of showed this a little bit in terms of the binding to the message that he had earlier on. And if we flick to my slide, we have this kind of arrangement that really shows the relationship between data binding and so on. One of the key things, I draw your attention to the data binding box in the center. Beneath there, we see that we have a string that is encapsulated with curly brackets. These curly brackets are used in a value definition in XAML to indicate that the following is an expression, it's an extension that's going to be evaluated. We then have the word binding, which indicates that this is the binding extension. So there is a whole syntax associated with binding that we're going to explore a little bit. But the key thing to understand around data binding is it takes it from an object and a property, which, as Jerry mentioned, can be a CLR type, such as the view model, but can also be an element. The data source can be something else. It doesn't have to be an object.
Right. You can bind to a class, a C# class of data.
Yep.
Or you could bind to the text box.
Absolutely. The other side of the binding is going to be a framework element and a dependency property. It's something that we're going to assign a value to, and it's going to be reflected in. In this scenario here, we have a text block. We're assigning a message to the text of the text block, and so that receives it. The other interesting thing is the binding expression has a lot of extensibility built into it. There's a lot of flexibility, a lot of things you can do. One example is, we mentioned this earlier on when we were talking about red and it becoming a solid color brush, is sometimes you might have a property that says true or false, and you want to manipulate that and make that Boolean.
Yeah, you want it to say yes, no instead of true or false.
Absolutely, more user-friendly perhaps than programmer speak. Those are situations where you would use a value converter, and we have a syntax around that. So let me flick on. The challenge with that is the more flexibility you have in these expressions, the more complex they can be in terms of definition. So there are a lot of flexibilities, and there's some shortcuts that the designers have put into this expression. So you can just turn around and say binding. So if you look at this top example, binding, this is just going to inherit the data context from the encapsulating object. And so as Jerry was talking about how this can roll down from the top, so if we bound to a view model called Jerry, then binding here represents Jerry. And that's what's going to be passed into this control to be displayed.
I have to go back to the designer again, because the designer is very powerful. One of the reasons I go into it is when I'm doing data binding, and there's always data binding in a XAML application, sometimes that syntax can be hard, right? I mean, really it can be. I mean, I know the syntax particularly well, and I still get it wrong every once in a while. I mean, that's just reality. The designer has a binding UI, and it allows you to select what you're going to bind to. Then it allows you to drill in, select the property that you're going to bind to. Then it allows you to select which converter you want to use as well. That sort of syntax, I mean, after you see it 100 times, then you'll never forget it. But the reality is, until you totally are comfortable with it, it's nice that the designer can guide you through it, build that complex syntax, and kind of prevent you from making just common mistakes as well. So when you look at the syntax, you're like, holy Moses. The reality is, I look at it and I don't think that. I think that's pretty straightforward, but that's because I have that familiarity with it. If you don't, the designer is there to help.
Absolutely. So there are a lot of properties you can specify in the binding, and as Jerry mentions, it's much, much easier to negotiate these things through the design tool. However, it's somewhat useful to be aware of these things in terms of we've shown very simple binding to properties, but you can do very complex deep binding. In fact, if your binding, say, exposes a property called customer, and that customer object has a customer name property, we can specify using dot syntax that your binding resolves down to customer name. You can do array navigation and so on and so forth, which is very, very powerful.
Yeah, it's nice. You can even specify the index of the item and then its property, and it's really neat. It
is very neat, and it solves a lot of problems that people sometimes try and solve in code by taking a complex relationship and rolling it up to a property that's exposed at the top level of the view model, whereas if you actually use the syntax that's available to you,
you can drill into it automatically.
Drill in that way. We mentioned converters. We can also specify that a converter should be using a specific language. If we want to show a different translation, we can specify a converter
Oh, back to
language.
localization, what we were
Exactly.
talking about before. If you convert it now to yes, no, that true or false.
Yep, we want to be
then
able to
you've
use...
broken it, right? Yeah.
Exactly. And I think a lot of this stuff is actually much more interesting showing in a real sort of code scenario rather than going through this statically.
Let me do that. I'll show this is kind of the classic demo that I love to give. And so this really shows element binding, and it talks about, and it really interacts with dependency properties. So earlier we were using a view model, so I won't use a view model for this. I just want to show how you can bind to anything else that's on the page. So I still got that view model up here. I'll just get that out of the way so we don't think about it. All right, so I have on my page here, I have just my red rectangle, right? Still there, nice. But I'm using a render transform, and a render transform gives us a lot of power, and one of the things it does is it gives me the ability to scale the size of something using the GPU to do the scaling, right? So I only bring that up to say I've set it now at 1.1, which means it's a 1/10 larger than what I actually set it to be. Now, at the top of the page here, I'm going to add another control. In this case, it's going to be a slider. And so this really shows off the coolness here. So I'm inside the toolbox. I want to find the slider. I don't see it here, but every toolbox inside Visual Studio 2012, I can do a search. There's the slider, right? And so I'll have a slider right here, right? We'll make it a little bit larger. Oh, added 2 by mistake. There we go. All right, so this is the slider, and here's what I want to do. I want to make it so that as I make changes to the slider, it alters the scale of the rectangle. And so here's how we'll do that. I'll go into the rectangle right here. I'll do it all in the designer to make it easier. If I go to the properties of the designer, if I go to the properties of the rectangle, I can see that down sort of low is the transform group. Oops, I clicked it by mistake. Here's the transform group right here. The transform group is how I interact with those render transforms. We're not going to talk about transforms. I just want you to know that that's how I'm doing it. This is the scale tab, and you can see 1:1 for X and 1:1 for Y. If I were to change it, in fact, let me make it so that you can see the designer while it's open. If I were to change this 1:1 to say 4, right, then you can see that the X and the Y, you can see that it scales one direction but not the other. And so I'll go back to 1:1, and I don't want to hard code it to 1:1. Instead, I want to code it to whatever the slider says. So here I'll say, remember I said the designer can do most of the binding for you and create all the proper syntax. So here I'm creating a binding on the X only. So you gotta click this little square next to it. So I clicked it, I selected create binding. What do I want to bind to? I want to bind to the element name, right? So we added a slider, I didn't give it a name. This will make sure that it has a name. Again, that's the designer kind of taking care of you. A slider has a value, so I'll go down to its value. And this is important, Darren, because value is a dependency property. And if we're going to do binding and animation, dependency properties are very valuable to us because they implement that change notification. And so I'll go ahead and say that I'm bound to 2 things. I'm bound to this slider and its property of value. I'll say OK. And now if I were to go back to the XAML, you can see that X now, here it is. You can see the syntax is really nice. It's binding to, this is the property name, and this is the element name. You can really make sense of it when you just look at it. And so I'll do the exact same thing for Y. I'll do it in code this time, so I can just kind of rush through it. And done. All right, so now X and Y are set or bound to whatever the value of slider is. And so I'll make a few changes to slider to make this work. So I'll go to the properties of slider, and I want to make sure that it's minimum, right? So 1 is 100% scale. And so I want to make it so that it goes, let's say maybe 3, so 300% scale, down to, let's say 0.5. I don't want it to actually disappear. And then we'll make its current value, right here, just 1. So it starts where you would want it. All right, that's it. That's the entire piece. So I have a slider that goes between basically 0.5 and 3. And then I have the rectangle that is scaling itself based on that value. So if I were to run this, Darren, do you think it would work?
Sounds good.
All right. I'll back it from 1. Now what's going on? Back it from... Darren, you promised me... No, I'm only kidding. Doggone. All right. It's great. Gosh, the encouraging chuckles from the peanut gallery. All right, so let me fix what's going on.
How did you spell peanut?
It's that doggone... Yeah. Barry.
What?
All right, so let's see. The maximum is 0 and the minimum is 0.5. How did it get maximum of 0 when I set it to 3? Anyway, doesn't matter. Now it's going to work properly. All right, so now I'll run it again. And now when I grab the slider and move it around, see it's set over here because we know the 3 is way over there. Now you know it's much better. And as I move it, it changed it, and it's snapping very coarsely. I could change its step frequency, right, to be. Let's see. I'll stop debugging. I'll change its step frequency to say 0.1. That'll make it a much smoother transition as it goes from one value to another, and then it's very cool, right? And so, how much C# did I actually write here? Not a single line.
Not a single line.
Not a single line. All I'm really showing is the binding power. Now, how much code is actually behind this to make it all work? Tons. But XAML rolls all that up and makes it so all I have to do is just kind of look at the declarative syntax and make sense of it. Look, I mean, that's only a handful of lines. If I didn't bring everything down into separate lines, it'd be even shorter, of course. But very powerful. I can bind now one-way and two-way, and that's kind of important. Right now it's one-way, that's the default. Basically, the slider is writing out its value to something. And if I were to make a change directly to the rectangle, it doesn't change the slider, right? Because it's one-way. But there is two-way. Why would I care about two-way?
Well, two-way is really important. Say, for example, you've got a text box, and you've got data that's in your view model that you want to show in the text box, but also as you type into that text box, you want to be able to push those changes back into your view model. If you've only got a one-way or a one-time binding, then that change is never going to make its way back to your view model. So you have to declare that you need two-way binding in order for that to work.
Yeah, if you have a data entry form and you have one-way binding,
it's not very useful.
It's kind of silly.
It's an exercise in frustration.
And trust me, it's not one way into the class. It's one way out of the class.
Exactly.
Yeah, no doubt about it. Then you mentioned one-time binding. That's the third type.
Which is the most efficient because one of the interesting things is obviously there's processing that goes on behind the scenes. If you know it's a one-time load and you're just going to display it one time, then there's no point in having any other more sort of dynamic binding because there's processing cycles being leveraged to monitor the state of your data and the state of your controls.
It basically reads the value and then forgets about it, and it's whatever it was when it loaded.
Exactly.
And if you don't implement iNotifyPropertyChanged in your view model,
then you have virtually implemented one time anyway.
That's right. That's exactly right. Because all of the others are using all of the events to monitor changes. That's exactly right.
So one of the interesting things, we kind of talked about a little bit about converting data. And so there is a interface that is declared, iValueConverter, that allows you to specify how data is converted. And so there are two methods that you need to implement on the iValueConverter. Convert, which receives an object, and you return back an object instance, and you're responsible for manipulating that object, and I'll show you a little demo in a second.
Okay.
Convert back works the other way. So if you have two-way binding, convert back is used to take the value from the control and convert it back to how you want to represent it in the view model.
So the first example would be I could convert true to yes, and convert back would take true, or could take yes
and convert it back to true.
Back to true because you might need it.
Now, one of the interesting things is in a lot of these value conversions, they really are only read-only. That most situations you say specifying the background should be red. Nobody's going to go in and change a rectangle's color through interacting with that rectangle to blue. And so you're not going to need to push back blue into the whatever bound that data. So often it's not implemented. By default, you could put in a throw not implemented exception and so on.
Yeah, 99% of the time, convert back is a not implemented method.
But remember, because it's an interface, you still have to have convert back declared in your value converter.
Now, if you don't do convert back and you're using two-way binding,
there's an exercise in disappointment.
Nice.
Okay, so let me show you a quick example of using or creating and using a value converter.
All right.
Boom, 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 boom. So what I have here is something very similar to what Jerry was showing beforehand, but what I have is two text boxes. This text box is called name. This other text box is using element binding to get back to name. And if I run this quickly, we can see something very similar to what Jerry was showing before is we can see that the lower text box is updating based upon me making changes to the upper text box.
Brilliant.
Now, what we're going to do is we're going to create a contrived scenario where the bottom text box has to always be in uppercase.
Yeah, so the bottom text box should always be in uppercase. How do you do something like that?
Well, we can use a value converter. And so one of the interesting things that we can do is actually declare and create a value converter. We could do a bunch of this stuff in code behind. We could respond to text change events, and we could directly write into the lower text box if I declared it with a name and do it in the code behind. I could hook up binding, go through a view model if that's what I wish to do.
Now, the downside of doing that, not just the amount of code, but you would literally have to change the value inside your view model to show it as uppercase.
Exactly.
The converter you're about to demonstrate changes it just in the UI, so it doesn't impact the value of the data in the view model, right? And so there's no view model, but in this case, you never actually change the value, you just display it differently.
Yep, so here's my class. I'm basically saying I need to implement iValueConverter. So if I say implement this, then I get my templates. And so there's some interesting parameters that we get passed in. So we get the value. So this is the value that we're intending to convert. You notice it's not strongly typed, it's just an object. So we need to make sure that we do any checks around this.
Because this is a simple interface, right? It doesn't know that it's a string or
Exactly.
a number.
Target types, this is where the destination's going.
Yeah.
We can optionally supply parameters to converters. Say, for example, we had a visibility converter and we wanted to invert whether true made it visible or hidden.
Yeah, sure.
We could supply a parameter here that swapped that behavior. And also, this is where we can specify the language. So if we wanted to do something different, si or no, or whatever, to be able to respond to different languages.
Right. That parameter is really handy. I mean, it seems like just another thing, but it really is handy. You can really make a converter do a lot of different things.
Exactly. Now you can argue, well, why don't I create 3 different converters? And so, it can stop code bloat by having these different parameters to change behaviors.
Yeah.
Convert back, as we mentioned, does the opposite sense, but as you see, it receives the same parameters because it has the same declaration. It's the same declaration on the object, it's just working in the opposite sense. And we're going to leave the good old 99 percentile implementation there.
Yeah. I want to go back to parameter one more time. So the value is set by what you have bound. And so the binding syntax shows it. And you might be tempted to try and bind the parameter as well, because you might want to pass in something else that's coming in. You can't do that.
Correct.
Parameters are not hard-coded is the wrong word, but they're not bound. They're hard-coded.
So we can put some error checking in here. We're making the assumption that the value is a string.
Excellent.
And so we want to ensure that assumption is valid, so we can do just return back an empty string if we want to, or we could put some sort of diagnostic error message in there.
Yeah, makes sense to me.
But
and you need to do this every time because, again, it's object that's being passed in. Something could be messed up on the UI side.
Exactly. And so now we're just going to turn around and say, we know that this is true because otherwise we won't get that.
Yeah.
So the value is string. And so now we can just turn around and say return value
val as string.
As string. And it's as simple as that we've now created a converter that will take the input string. So how do we use it? So we can come into here, and now what we can do is specify in our resources that we wish to access the uppercase.
Now that's going to be local, or where'd you put it?
So this is going to be within this namespace, and
I see. You've got something extra installed, I think.
I should have. Oh, if I type it correctly. So now I can basically turn around and say, add this into my namespace. So it automatically added local, worked out where it is. I have an additional developer tool that helps me do that.
Yep.
Because we're creating this in the resources dictionary.
Called ReSharper.
ReSharper, yeah, by JetBrains.
A lot of people love it.
A lot of people love it. Been using it for years. Can barely use Visual Studio without it now. I end up typing all the random key presses if it's not there. So resources is a resource dictionary, and we're going to be touching that a little bit later. But one of the key things with any dictionary is, overloading the word, is you need to specify a key. So you can identify your converter or whatever object you're using. But it's in the X, not the S.
Very good.
You were just going to leave me hanging there, weren't you? You were just waiting for me to
I thought you used that as a placeholder.
Yeah. So then the syntax to add a converter is it's just another binding parameter, and then you use another extension, static resource,
Yeah.
and specify uppercase converter.
Yeah.
So that tells us that any time that this binding expression is evaluated, we use this converter. So now if I run this, here's my text box, and if I type in lowercase, we can see that the value converter is running instantaneously
Yeah.
and promoting.
As the binding occurs, it detects a change, reads the current value, first passes it to the converter passes back the result, then displays what that result is. It really does inject itself into the pipeline.
Absolutely.
Yeah. Here, do one thing for me. Take away the syntax of the converter that you just added there. Yeah, just so back to where it was before. And then delete the reference at the top. I just want to show how you might do this in the designer, because the designer gives you a lot of capabilities as well. So go ahead and go to the properties of the second text box. And so if you go to the text property and click the little square to the right of it, this is where we get to it. So it's right, yeah, there you go. You got to give it a little more width. Yeah, so everybody should have this inside Visual Studio, and then from there you can go to create data binding. This is the same process that I went through, but then at the bottom what I didn't do was this. So it says, which converter do you want? We removed it, and so here it gives you the ability to add it. So there's that converter that's inside your assembly.
So that's basically reflecting upon your assembly and finding all the implementations of iValue Converter.
That's what it does, exactly. That's exactly right. So it does a lot of the work for you, and if you say OK now, it goes ahead and adds it to the resources. Well, scroll up just for a second. Adds it to the resources, just like you did, and gives it a different key, and then also adds the converter syntax for you as well. Right? So there it is.
There's always multiple ways to skin a cat.
Yeah, it's good to know that if you are watching the demo, I mean, the reality is I type my converters by hand. I always do, right?
Yep.
But if it crossed my mind that I might get it wrong, or if I had an error and I couldn't figure it out, I would probably do what you just did, and that is to use the designer to do it for me. The designer does it right. If it happened to already have been in resources, it would have shown up in that drop-down list rather than adding it for you.
Okay, so let's do a quick recap of what we covered.
Yeah.
So we touched upon the layout controls, the three...
Wow, was that this module?
That was. Time flies when you're having fun.
Wow.
So
That's right, the three core ones.
The three core ones, and we kind of explored the view box and the scroll view as well, in terms of how you can create more complex layouts and respond to overcapacity imaging.
As well as the wrap grid and the variable wrap grid that you would use in some repeater that would inherit from items control.
Absolutely. And then we explored data binding in a little bit more depth, really sort of explored the syntax associated with data binding and how we can leverage converters to help us manipulate those values.
Right, you can bind not only to data but also controls, and then you can leverage these converters to do amazing things.
Absolutely.
And bind it multiple directions.
Sounds great.
Let's take a 10-minute break and come back to Module 4. See you in 10 minutes. It's not lunch.